Yeah.
It can't dip below because there's no critical points.
It can't dip below because there are no critical points. What a precise and correct answer. So that's exactly right. The point here is that because f prime is not 0, it can't double back on itself because there can't be any of these horizontal tangents. All right? It can't double back, so it can't backtrack. So sorry, if f prime is not 0, f can't backtrack. All right? And so that means that it doesn't look like this. It just goes like this. All right? So that's basically it. That's practically the end of the problem. It goes like this. All right, now you can decorate your thing right. You may notice that maybe it crosses here the axes. You can actually evaluate these places and so forth. We're looking right now for qualitative behavior. In fact, you can see where these places hit, and it's actually a little higher up than I drew. Maybe I'll draw it accurately so that you can see it, as we'll see in a second. All right. Anyway, so that's what happens to this function. Now, let's just take a look in a little bit more detail by double checking. So we're just going to double check what happens to the sign of the derivative. And in the meantime, I'm going to explain to you what the derivative is and also talk about the second derivative. So first of all, the trick for evaluating the derivative is an algebraic one. I mean, obviously, you can do this by the quotient rule, but I just point out that this is the same thing as this, all right? And now it has whoops, that should be a 2 in the denominator. And so now this has the form 1 minus 1 over x plus 2. So this makes it easy to see what the derivative is, because the derivative of a constant is 0, right? So derivative is just going to be, switch the sign. This is what I wrote before, all right? And that explains it. But incidentally, it also shows you that this is a hyperbola, right? These are just two curves of a hyperbola. Okay, so now let's check the sign. It's already totally obvious to us that this is just a double check. We didn't actually even have to pay any attention to this. It had better be true. This is just going to check our arithmetic. Namely, it's increasing here. It's increasing there. That's got to be true. And sure enough, this is positive. As you can see, it's 1 over a square. So it is increasing, so we checked it. But now there's one more thing that I want to just have you watch out about. So this means that f is increasing on the interval minus infinity x to minus 2, and also from minus 2 all the way out to infinity. So I just want to warn you, you cannot say, don't say f is increasing on minus infinity, infinity, or all x. Okay, this is just not true. All right, I've written it on the board, but it's wrong. I better get rid of it. There it is. Get rid of it. Okay, and the reason is, so first of all, it's totally obvious. It's going up here, but then it went zooming back down there. And here, this was true, but only if x is not negative 2. So there's a break, and you've got to pay attention to the break. So basically, the moral here is that if you ignore this place, it's like ignoring Mount Everest or the Grand Canyon. You're ignoring the most important feature of this function here. If you're going to be figuring out where things are going up and down, which is basically all we're doing, you'd better pay attention to these kinds of places.